Hello, everyone. Welcome back to another vegetable production class. Um, Today, we're talking about factors that affect production. And this picture is showing some fall mums or chrysanthemums on the right and some peppers or capsicum on the left. Obviously, ornamentals and vegetables are very different. Um, Vegetable crops actually are a little more complicated. One of the biggest differences is that they're indeterminate, right? So it's not like you plant a seed and then it grows into a fall mom and then it blooms and it's done. That's determinate. Our vegetable crops just keep going until we decide when they're going to stop. So they're anywhere from say 3-4 months for cucumbers to 10 months for peppers and tomatoes. There's also a lot of rules around crops that are eaten, which makes sense because you're not going to eat your fall mom, but you're going to eat your tomatoes. So there's a bunch of things like that we're going to get into in this course. Um, Definitely growing vegetables is smaller margins, no doubt about it. But there is a larger marketplace. So that's a trade-off. But vegetable greenhouses tend to be bigger for similar profit margins because of that. But at the end of the day, because there are smaller margins, you have to focus on maximum yield, being very efficient with labor, energy, and input costs. And oftentimes that involves using a lot of technology, right? So it's a sophisticated technology. Using things like RFID tags to track plants and staff movements for food safety and productivity, for example, or automated carts for bringing the produce from the greenhouse into the packing barn to save on labor. And a lot of energy goes into the genetic breeding of plants for yield and disease resistance. And increasingly, believe it or not, flavor. Yep. I think they got that message loud and clear. That's been getting better every year. Um, but beyond pests, disease, and all those other things we talk about, what is a really serious challenge? And I have alluded to this in the fall, so maybe it's not totally new to everyone, but a daily challenge is maintaining plant balance. So this lesson is going to talk a lot about plant balance and what does that mean and how do we achieve it. And I'll be upfront, we're going to come back to this topic a lot as we go through the different crops, tomato, pepper, cucumber, because there's some nuances for each crop. But this is the introduction to plant balance and all the factors. Um, so typically, it's a balance between a vegetative growth and reproductive growth. So right. So when we look at a plant, is it in a high reproductive mode or is it highly vegetative? Is it producing a lot of flowers and fruit, or is it producing a lot of leaves? On the surface, that's the simple perspective. And then how do we achieve it, right? How do we maintain that balance? And I've got a long list, but it's things like climate, nutrition, and plant management. How you train it, prune it, shape it, that kind of thing. So let's look at what a vegetative plant is, right? So it's a plant that's producing more leaves than fruits and flowers. And that means that vegetative growth is dominant, right? So typically there's fewer fruit and they are smaller in size. And then when we look at flowers, they tend to be fewer, very large flowers. And I should add that their colors are less intense. And in tomatoes, for example, the petals are less curled back, they're more facing forward. Um, what is the aim of the vegetative stage? I mean, obviously, vegetative growth has a purpose, right? It's useful, and it's for producing leaves, strong stems and pedicels, and strong root systems, right? So the idea is that you want strong vegetative growth so you can sustain large yields for a long time. So vegetative growth is usually very important early on when you're establishing your plants. And then as the crop is growing, making sure there's enough vegetative growth to keep the plant strong to support the growth that's on it and not, overproduce and tax the plant. Overly vegetative plants tend to have large, thick, dark green leaves. and they have thick stems. Remember, we discovered that a little bit more with St. David's, talking about the thickness of the pepper stem. They tend to have less fruit production, which is bad news. And they have a strong head. We're going to get back to this one because this is a little confusing. But the top of the plant, the growing tip, the head of the plant is full of thick young leaves, and I'm going to add with good dark green color. What happens when you're too vegetative, right? It causes reductions in flowers, which of course means less fruit and less quality fruit. And it delays fruit maturity. So all this costs you money. This is all hurting your bottom line. So it's something we want to avoid. Generative. So when plants are generative, I'm going to use the term generative and reproductive interchangeably. So plants that are generative are producing lots of flowers at regular intervals. And they have production of fruit at regular intervals. And the production of flowers and fruit are decent quality and size. And you might say, well, that all sounds good. Why don't we just keep the plant generative? Well, the problem with that is that there's only so much sugar to go around. And if you have too many fruits on the plant, then what happens is the sugar, there's less sugar to go around, and you have poor tasting fruit, weaker fruit, and a weaker plant. You can actually set the plant back. And after a flush of excess fruit, the plant, once those fruits are removed, the plant will sit there and do nothing for a long time. So you may think, oh, I've got high yields, but if you average it out over several weeks, you actually have a lower yield, because you got that initial big flush and the plant did nothing for 3 weeks before it set fruit. It would just drop flowers, abort them, and you get nothing as the plant continues to grow and recover and restore its sugar. Remember that carbon to nitrogen ratio, right? The sugars deposited in the plant are critical. So generally, generative plants have smaller leaves as opposed to vegetative being bigger, thinner stems as opposed to vegetative being thicker, smaller flowers as opposed to vegetative having bigger flowers, and the flowers in a generative plant are a much more intense color, better coloration. Unfortunately for peppers and eggplants, well, mostly peppers, the flowers are white, that really doesn't help you too much. It's like, ooh, it's extra white. No. But, so smaller leaves are not so bad in that they shift sugar distribution to the flowers and the fruits. So again, this all sounds wonderful. Why don't we just keep the plant generative? Well, because we can't sustain it. So excessively generative plants, right? So small leaves, thin stems, small, intensely colored flowers, very large fruit load, lighter green leaves, they're running low on nitrogen, and the leaves start to get lighter, there's less chlorophyll, and the head of the plant becomes weak, which means smaller, thinner leaves forming at the peak, and often a weaker color. So, and you'll see flowers forming higher up in the plant. So typically with our new lights at the college, I'm seeing that they're producing way more light than our old lights from last year. And the photo period that we've got them on is very stressful. So the plants are quite generative. Wouldn't be surprised if there was a dip in productivity by the time or while we've been gone. So balance is needed, right? We need the right amount of vegetative growth to renew the plant, to replenish its carbon, and we need enough generative growth to make sure we have the plant producing. So we need balance. So proper production of fruit and the correct load so that it can support that fruit and not have problems. So that means we need sugars to support the fruit growth, and that means we need some vegetative growth for leaves. We need healthy, good-sized leaves for that sugar production, again, for that carbon-nitrogen ratio. And as far as a root system, we haven't talked a lot about that. We want every day the plant grows new roots, typically in the evening, and so having that good vegetative growth sort of helps with root growth. But I'll be honest, generative conditions often support root formation because the plants are looking for nutrients, right? So that's a case where almost like a generative environment is going to encourage root growth. Whereas if you baby the plant, the roots are not as necessary to get less root growth. Um, and of course, the most important part about having the plant in a generative state is it's going to produce flowers, which ultimately contributes to our yields. So balance is absolutely essential. Too vegetative, productivity drops off. Too generative, and then you get this long gap where there's no fruit. Yeah, too many slides here, but I had fun making that one. You see the plates? I mean, who makes these icons? That's astonishing. We're balancing plates. And I'm going to be honest, but you know what? This individual is not contributing substantially, and same with this one here. He's more concerned about the camera. I'm considering firing them from the tug of war event. They're just not contributing. When to use veg or gen? So, there are times when you may want to shift the balance, and generally speaking, when you're starting the plant out, that's a time when we want to get good root development. I've talked about this last term briefly, but so typically we grow the seedlings in little rock wool cylinders, and we transplant them to small blocks, grow them for a while, and then we put them on top of our bags, right? You did that, you planted in the fall. And the roots generally will penetrate the block, but we kind of remember if we use low EC so that the roots were encouraged to look for nutrients to root into the bag. And we had a fairly warm, humid environment, and that was allowing us to get the plant established. Now, the external climate in the winter or in the summer, depending on the season, has an impact on the generative or vegetative tendencies of the crop. And growers in Holland, for example, where it's dark and humid and a more vegetative climate, they typically take those blocks and put them on the bag, but not over the hole for the first week or so. And that sort of stresses the plant out a little bit. So it starts to shift its focus towards being more generative. And then they place it on the bag so that it can root in. But at that point, the plant has committed to being more generative. So they get earlier productivity, even though the climate is, the time of the year and the climate for when these crops go in is a vegetative climate. Yeah, so generative growth, you can only do that when the plant is large enough. So remember we talked about with determinate and indeterminate, when the plant's going through its first juvenile growth until it forms its first flowers. That's the only time when generative growth is beneficial, is sizing it up potentially if your climate's suitable. But, balance is critical. So oftentimes we talk about growers reading a crop or assessing it. And there's several ways you can do that. There's visually, but I'll be honest, the main method is by collecting data on the crop. And typically the stem diameter is measured at the top of the crop and it's plotted. And you go back to the same vines regularly and you plot that size. So when they plot the stem thickness, they can see if the stem is thinning or thickening. And that gives them a tendency to see if the crop is actually shifting towards vegetative or reproductive growth. The reason why that method is better is because they're seeing the crop tendencies far sooner than if you waited for leaves to grow and branches to form and flowers to grow. It's too late, or you're always late in making the corrections. So the closer you are to maintaining that perfect balance, the higher your yields will be. And so visually looking at the crop and reading it, it might look in the sense that, let's just skip on here. This one here, if we're looking at the top, it's going to look thick and dense. There's lots of leaves. I don't see a lot of looseness there. This is a very leaf dense crop. There's not a lot of light penetrating lower into the canopy. That is a very shaded environment. So that's going to shade the crop. It's going to shift it towards more vegetative growth. Not a lot of flowers at the top. They're down lower in the crop. Looking at this one, if the top, you can see through the top. It's very loose. So that is a more of a generative crop. But again, like I said, the correct method is metrics. You know, the grower goes along, regularly measures the stem thickness in a zone, a couple of zones throughout the greenhouse, and monitors that to make sure or make changes in the greenhouse climate. Here's some more pictures. On the left is a generative crop. Again, you can see looseness. The leaves are a little less dark. And on the vegetative side, the leaves are thicker and it's a darker green. And here there's a lot of flowers. There's still flowers in the other one, but not as many. So factors that affect the type of growth. We're going to break these down and look at them. So light is the first one we're going to look at. That is absolutely critical, right? We know that plants need light, and we need around 1,500 joules per day for a tomato crop as a minimum, and 6 hours of light duration in order to set fruit. So that's a useful bit of information there for you. 6 hours, not bad. That way we can set fruit in Ontario just about any time of the year, as you know, because we did at the college right through Christmas. But typically, and this is not so hard to do, we have lower light intensity when you have lower temperatures. And we have higher light intensity when you have higher temperatures. And the main reason why is precisely what it says here. So the sugars don't get stuck in the leaves. You can imagine if you've got high light intensity hitting the leaves, they're making all kinds of sugar. But if it's cold, the sap isn't flowing, and the sugars don't actually flow out of the leaves. They get stuck, and then they get converted to starch, and then they're no longer of use to the plant. They can't really be reallocated easily. So we try to match the temperatures with the light intensity. So as the temperatures get warmer, as the light gets brighter, we have warmer temperatures to help shift those sugars to the fruit and away from the leaves. And if it's cool, with low light, we run cool temperatures. Typically, Leamington, Southern Ontario, there's very good light for 8 months of the year and reduced light intensity for 4 months of the year. As far as winter productivity, it's hard to say. It depends on your customer base and stuff like that, but growers are always experimenting with grow lights, and in recent years, they've started putting them in. I think partly because hydro costs have gone down and lights are inexpensive. Well, HPS lights are relatively inexpensive to buy. They don't do the whole range though. They often do a section so that they can meet winter demand. It's not nearly as intense as the demand is in the summer for vegetables. It seems like people are mostly meat and potatoes in the winter or pasta. I don't know, but this is a 75-year average. There's a lot of data here. This is the number of hours per month. So, again, December, January, they're the worst. March all the way through to October, excellent for productivity. So, again, good reason for why Southern Ontario is such a good place for growing good crops. And yes, artificial lighting is used regularly. It's expensive because they use a lot of electricity, but you can maintain customer bases. If you stop supplying in the winter, often wholesalers go to Mexico and get their produce. And if you want to maintain that supply line, you try to run a section with grow lights to keep it going. You don't necessarily make as much money, but maintaining a customer is just as valuable. Or sometimes keeping your staff occupied and having a wage instead of shutting down is also a good thing to do as a business. So December, January, supplemental lights are the most important. You're looking at 12 months versus 10 months, depending on grow lights. But definitely you get slower fruit ripening and less sweetness in the sugars in the middle of the winter. So grow lights definitely help, but they're not the end all and be all of it. Temperature. Let's look at temperature. How does temperature affect the balance of plant growth? Temperature affects how chemical reactions happen, how fast they happen, right? So it influences processes like photosynthesis and respiration. So, and of course, the net effect of both photosynthesis and respiration is growth. We need both. So temperature is critical. Um, so as the difference between day and night temperatures increases, so the gap, the bigger, as the gap gets bigger between nighttime and daytime temperatures, the crop becomes more reproductive or generative, right? So it's not too hard to do cool nights in the winter because it's already cold outside, and then float higher temperatures, in the summer if you want to split that gap. So, and obviously we can't control the outside temperature, but we can kind of influence the difference between day and night. So during the day, we can run a little warmer and try to cool right off as much as possible at night to get that bigger gap if we're trying to steer the crop towards being more generative. But obviously you can't be too cold or too hot. There's sort of a happy medium. Uh, Typically, we do not have nights warmer than the day because that obviously will trigger lots of respiration and lowers the sugars in the leaves. It stresses the crop out. So, negative diffs, not done. If there's very little difference between day and night temperatures, we have a vegetative climate. So we get vegetative climates when there's little difference between day and night. So as the temperature gap widens, it's more generative. As the temperature gap narrows, it's more vegetative. So that's a pretty straightforward thing that you can change. Say you're measuring your stem thicknesses and you're seeing the crop is tending towards being more generative, then you would bring your day and night temperatures a little closer to steer the crop towards being more vegetative, and then keep monitoring your stem thicknesses. Other things temperature affects are leaf size and quality, so color, formation, stem thickness, which we talked about, and of course flowers, and that obviously turns into quantity and quality of fruit. Now, one of the interesting things about temperature is it impacts pollen and pollen formation and dropping. So if your temperatures are not right and you don't get proper pollination, you get deformed fruits, or what we call cat facing. I've got some slides coming up next that show that. But what normally happens here is that the pollen, when it lands, so the anthers are these cone-shaped exterior parts are the anthers. And there's your stigma. The pistil goes down the center. So like in this picture, these anthers, they'll dehisce, but the pollen, when it's on the stigma, doesn't grow properly when the temperature is either too hot or too cold. So 21 degrees Celsius is the normal growth temperature for pollen. So if you run really cold temperatures in the winter, you run the risk of having poor pollination. So it's not always as easy as just lowering the temperature. You can do it for a couple of nights sort of thing, but you have to be careful. So deformed fruit can be related to root pressure and temperature in this regard. We saw this in the fall in our cucumbers, but that had a lot to do with poor root development and not getting water into the fruit. Here's cat facing in tomatoes. So this is not blossom end rot. There's a difference, right? This is the bottom. This would all be black. This whole thing. Oh, here, let me draw it properly. So this would all be black in the bottom. That would be blossom end rot. But instead, it's sort of a ring or these traces where pollen didn't evenly fertilize the ovary, and as it swelled, it stretched and cracked. So that is a cat facing as a result of poor pollen tube formation from being too cold during pollen tube growth. Cat facing happens in peppers. You see how you get like a kinked or deformed side of the fruit? That is too cold for pollination. Here there's a purpling and a deformed fruit. So you definitely have it's too cold. And then at the very least, as you are running too cold, you also end up with reduced fruit size. And in fact, at the college, they are running quite cold in the back of the greenhouse. Not as cold as the middle, but it's cold in that back corner. So that explains why we had smaller peppers. So peppers are pretty good, but they were about 80% of the size that I would expect. We have talked about this before, the pre-night dip. That is still a very useful thing, right? Remember, before the night, we can use temperature to shift sugars to the fruit because they hold heat longer. But that is not so much in the shifting generative versus vegetative. That's more just shifting sugars to the fruit. Okay, looking at relative humidity and how it affects balance. Reminder, water vapor, when it's 100% humid, that means that the air is holding all the water it can. As air gets warmer, it can hold more water. So even though in all three of these examples, they have the exact same amount of water in them, nothing's changed. The only thing that's changed is the temperature. And so at the higher temperature, it's a much lower RH because the air can hold so much more relative to the total amount of moisture that's there. So in this case, we have 28% relative humidity. Here we have 52% relative humidity. And here we have 100%. The air cannot hold any more moisture. So just remember that humidity and temperature are absolutely linked together. There's no separating them. And of course, then that plays out in your VPD, right? Your ideal vapor pressure deficit to make sure that water is flowing through the plant, that you are having actual transpiration proper, not stressful or inadequate. Anyways, as we increase the temperature, that decreases relative humidity. So this is linked to temperature. And also, as you increase humidity, we affect transpiration rates, right? So if the air is very humid, water is not evaporating from the plant, we have slower transpiration rates. The other thing that humidity does to the plant to impact its growth would be affecting pollen. If it's too dry, the pollen doesn't actually shed off the anthers. And if it's too humid, it clumps and you get less even pollination because only a couple of pollen on the bottom are in contact with the stigma and germinate, while the top of the clump doesn't. So you get uneven or insufficient pollination. Anyways, going back to transpiration stress, if you lower the humidity, we have a reproductive or generative environment. And if you raise the humidity, we have a vegetative climate. So that's a really important one. So low humidity, stressful, generative or reproductive growth. High humidity, low stress, but decreased transpiration, we have vegetative growth. So, and remember, if you go way off the charts and you have way too much transpiration, it's way too dry, the stomata actually close and you don't get any growth. So that's an important thing to keep track of. So moving on to irrigation from that. Typically, this is what a typical irrigation day looks at at maybe 8 or 9 in the morning. Sometimes earlier, you're going to give your first little shot of irrigation, and then another one, and another one, and another one, and another one. You start getting your first leach somewhere around lunchtime. The first bit of water comes out of the bag. And then you maintain that moisture level in the bag till your last irrigation, and then it dries down through the night. And then you start again. Now, how you do shots and the frequency of them impacts how the crop moves through vegetative and generative growth. And as an aside, you'll notice I have a folder in the weekly lessons that has a folder that has extra documentation on maintaining plant balance. So you might want to look at that. There's an irrigation one and then a general one. So what's interesting here is this is showing us the schedule. And crop steering is what we do when we're trying to balance the crop. So we start, 0 to 1 hour after sunrise. Your grow lights are on. Okay. That's vegetative environment. If we wait 1 to 2 hours, that's an earlier irrigation. If we start 1 to 2 hours after sunrise, it's kind of neutral. So you're in the middle of the balance. Say your crop is balanced and you want to shift it. You're going to start 1 to 2 hours after sunrise. If you wait even longer, 2 to 4 hours after sunrise, then you have a generative environment. The root zone is water stressed, and that shifts the plant into wanting to produce flowers. Remember, it's a survival response. Now, I'm not suggesting you dry it down to the point where you damage the roots, but the plants sense that difference. Your last irrigation, so stopping with your grow lights off, looking at the chart, if 1 to 2 hours before sunset, it's a vegetative environment. With 2 to 3 hours before sunset, it's neutral. And 3 to 4 hours before sunset, it's generative. So once again, if you look at this generative here and this generative here, you're starting way late in the day and you're ending way early in the day. So you're getting way fewer irrigation shots when the crop is being shifted towards generative. Whereas with vegetative, you're starting way earlier and you're ending way later. So the more irrigation shots you have, the more vegetative the crops. The fewer the irrigation events, the more generative. Then there's the EC, changing the EC. So if we have a lower EC, it tends to be more vegetative. When you have a higher EC, it tends to be more generative. And as far as water content, this makes sense because it's related specifically to what we just talked about here, right? So if we have a high water content, it's vegetative, lots of irrigation events. If you have a low water content, it's generative because you've had only a few irrigation events. So anyways, that's a really useful slide. Let's look at nutrients. Just talked about that, but let's review it again. So EC steers the crop, frequent supply and frequent drying, drying out, these sorts of things will steer the crop towards being generative. The type of nitrogen, we've talked a lot about this. Nitrate promotes generative growth, and ammonium promotes vegetative growth. I know you thought you were done with the nitrate ammonium thing, right? Lots of potassium can also be used to improve fruit quality and block excess nitrates because it competes. And that will also make the plant a little more reproductive. So oftentimes anyways, in the flowering stage, the fruiting stage actually, when the fruit's developing, we bump the potassium up and lower the nitrogen. We've talked about that lots. Okay, let's focus on the last one here. This is leaf pruning. Leaves, as we know, are responsible for several things on the plant. They make sugar. They store sugars in their vacuoles, they provide shade, and because of transpiration, they move nutrients around, right? They pull the water up, which also brings the nutrients up from the roots. So they're like the pump, the heart that moves everything around to keep the plant growing. Now, if we prune leaves, like remove them, we reduce shading over lower leaves, right? So in low light conditions, that can help shift the carbon nitrogen ratio. We shift the source sink ratio towards fruit. So if you get too many leaves, the fruit doesn't necessarily get the sugars. They end up staying in the leaves. So now there's a you don't rip all the leaves off, but you can remove a couple. As we look at the specific crops over the next few lessons, we'll look at it a little more closely. But removing leaves will generally stress the plant and trigger a generative response. And it's always the lower leaves we're removing, not so much at the top. Sometimes we do take a leaf out of the top if you're trying to make the plant more generative. That definitely does happen. But again, we'll talk more about that when we go specifically into cucumbers, tomatoes, peppers. So one other mention about, it's kind of related to leaves, like why would remove leaves? Because of plant density, right? All the leaves shading each other. So typically in hot weather, we can increase plant density because it helps with cooling. It also makes the plant a little more vegetative, where in hot weather, the tendency is to become generative. So leaving the leaves on helps balance the crop out. In cold weather, we want to, density has a similar effect. Opposite in the sense that if it's more dense, it reduces the amount of sugar that goes to the fruit. They end up stuck in the leaves, and it's that source sink ratio thing. Hopefully that makes sense. If you've got a lot of leaves and only a few fruit, then the sugars are not necessarily pulled into the fruit in the evening. They end up staying in the leaves, and the leaves take the sugar from the day and convert it into starch. And then it's locked into the leaves. It's not really available to the plant anymore. So we remove some leaves in the cold weather. Now, there are some unique angles between cucumbers, tomatoes, and peppers. So cucumbers, we can change the density at the time of planting because it's a short crop. So we can go less dense in the winter and more dense in the summer, right? Because it's a 3-4 month crop, we're going to rip it out and replant for the different seasons. With tomatoes, what a lot of commercial greenhouses do is they plant with a moderate density in the fall. And as they head into the spring, remember the vine is always growing and we're always lowering it and advancing it. When you get closer to the spring, instead of removing all the suckers, you leave a sucker and you grow a second branch off that vine. And then you carry 2 vines forward through the summer, which increases the density. So that shifts the plant away from being overly generative, but also increases your yields because now you have 2 branches that are bearing fruit. Nice little trick there. Unfortunately, with peppers, it's not a lower and tilt and advance type crop. It just goes up and then it's done. So we don't have the option of leaving suckers to grow. So typically what we do with peppers is we vary how much fruit is actually on the plant, so fruit load. So if there's too high of a fruit load, the plant becomes overly generative and it will weaken and then you won't have production. Remember in December, we had a big flush of peppers and then we had about, I think, 5 internodes with no fruit and then it started again. So by removing some fruit regularly, we can see if we can get a regular productivity from the vine and not get it out of balance. This is just a slide summarizing all the different factors that impact vegetative and generative growth. It's kind of for tomatoes, and we'll probably see this again when I do my tomato lesson. But you can see larger, greener leaves, fewer fruit on the vegetative side. And on the generative side, smaller, lighter green leaves, but lots of fruit. And so we want to keep this somewhere in the middle here. So we're not excessively one side or the other. So I'm going to let you review that slide when you're studying. I'm not going to go through the whole thing again. And then I made another short list myself to help you with your studying for the midterm. So summarizing generative versus vegetative triggers. All right. Well, I hope you found that interesting, and we're going to talk more. Again, I'm going to say we're going to talk more about this as we get into each crop specifically. And these are really important concepts. I can't leave them as just one lesson. We have to kind of keep going over it to drill it into you so that you instinctively know to think about plant balance. So please don't be offended if you hear me talking more and more about it. Okay. All right. Stay safe. Bye.